Now, in this video, we are going to take up a problem on projections of lines. How to solve this, how to analyze this problem on projections of lines. The problem reads as a line capital AB measuring 70 mm has its end capital A 15 mm in front of VB and 20 mm above HB, and the other end capital B 60 mm in front of VB and 50 mm above HB. Draw the projections of the line and find the inclination of the line with both the reference planes of projection. So this is the problem. So a line capital AB measuring 70 mm has its end A 15 mm in front of VP and 20 mm above HB. So he says line capital AB means what? It is the true length. Since it is the true length, that means it should be parallel to any one of the planes. A line has its end A 15 mm in front of VP. Where you can see the in front of VP you can see it in HB. So when you look from the top view, I can see the distance in front of VP here. So that when it is projected, that image will going to fall on the horizontal plane. So you have got small a here, which is 15 mm in front of VP and 20 mm above HB. Where exactly you can see the 20 mm above HB, I can see the distance in the vertical plane. You can see that this distance is above HB. So if you look from the front view, that image will going to fall on the VP. So you have A dash and you have A, and you have capital A and you have capital A here also. Now the other end B is 60 mm in front of VP and 50 mm above HB. So here he has given the true length, but he has not given the true inclination. But what he has given the other end point B, which is 50 mm above HB. So when the distance from here to here is 15 mm in front of VP, so since it is the true length, obviously the other end point B is also in front of VP by 15 mm only. But he says that angle is not given, but instead he has given the length, and he has given the height. What is the height he has given? 50 mm above HB. So what you have to do is, you have to take from here, you have to take 50 mm above HB, that is capital B1. But you don't know this, you know this distance, but you don't know the inclination. But you have given the other end point B, which is above HB by 50 mm. Where you can see that image, when you look from the front view, that image will going to fall on the vertical plane. You can see that you have the locus of B, which is already given. But he has not given the angle of this line, but he has given the distance. So this locus of B can be from here to here only. So again the locus of B what? The locus of B is parallel to XY. So which is at a height of 50 mm above HB. And then what you need to do? You take 70 mm with A dash as center, cut an arc on the locus of B, so that you will going to get the point B1 dash. Since it is the point B1 dash, that means that is A dash B1 dash is the true length of the line, whose length is equal to 70. So you mark this as capital A and you mark this as capital B, and this will going to be the locus of B in the front view. So obviously, since it is the true length of the line, both capital A and capital B1 is at a distance of 15 mm in front of VP. But A is above HB by 20 and B1 is above HB by 50 mm. So this is how you will be able to get this line in space, whose length is equal to 70. Once it is cut on the locus of B, naturally you got A and B1, where you can get the inclination automatically. So this inclination is nothing but the true inclination, because the length is in true length. So theta is the inclination made by the true length line with respect to HB that you have to measure in the end. Similarly, he says end A is 15 mm in front of VP. So you get 15 mm in front of VP. Where you can see the distance is seen in the horizontal plane by looking from the top view. Similarly, he says 60 mm in front of VP. So from VP, you measure 60 mm and draw a horizontal line which is parallel to XY. So where since it is the true length in the horizontal plane, so obviously that line should be parallel to HP. So that is NDA is above HP by 20. Similarly, the point B2 is also above HP by 20. Then only the line will going to be parallel to HP. So what is the position of B2? The position of B2 is in front of VP by 60 mm. So that is how you can see the end B2 is 60 mm in front of VP. So once you get this line, but you have not got the true length, but you have the true length line which is 70. Since you know it is the 70 mm line with small a as center, take a radius of 70, cut on the locus of B, the top view. So you join AB2. You join AB2. So that line will going to be the true length line, wherein you will mark that point as B2 and you mark this as capital A and capital B and this as the locus of B. So capital A is 20 mm above HP and capital B2 is also above HP by 20 mm. But capital A is 15 mm in front of VB, whereas capital B2 is 60 mm in front of VB. So this is how you will be able to write the capital AB2 in space and capital AB1 in space. Now, so what from this what you can say? You can say that A dash B1 dash is the true length, which is capital A and capital B in the front view, and AB2 is the true length, which is capital A and capital B in the top view. But in this case, remember, he has given the locus of points in both A and B in front view and top view. And he has given the true length line. What is the locus of B? The locus of B is the position of the end point B. Both the true length and also the view length will going to lie in the front view as well as in the top view. So that is the term of the locus of B. Now what we have done, we have identified the endpoint of B in the front, the true length of the endpoint B in the front view as well as in the top view. This is known. Correspondingly, the inclination theta with respect to HP and phi with respect to VP, you got those inclinations. Now how to write this in a orthographic view? So how to draw that? First we are going to draw the XY line and you mark VP and HP. As he has given the distance above HP by 20 mm, from XY line you measure 20 mm and draw a horizontal line. Similarly, from XY line you measure 15 mm in front of VP. In front of VP is seen in HP. Therefore, you draw a line parallel to XY line in the top view. And consider any point from there, from A dash, that is 20 mm above HP line. From there you draw a vertical line and you mark this point as top view point A and capital A in bracket, front view point A dash and capital A in bracket. So after that he says the other end point B. What is the other end point B? Which is 50 mm above HP. So from XY line you measure 50 mm above HP, it is seen in VP. So VP is above XY line. So you draw a horizontal dash dot line which is 50 mm above HP. Similarly, 60 mm in front of VP. In front of VP is seen in HP. Where is HP? HP below is XY line. From XY line you measure 60 mm and draw a horizontal dash dot line and you mark this point as locus of B and you mark this point as B2 and you mark this point as capital B. Similarly, you mark this point as B1 dash, capital B in bracket and the locus of B. Now, once you get this, now once you get this locus of B and then the locus of B, now what I wanted to do now, I want to take the true length line. True length line is given, which is 70. What is the term of locus of B? The locus of B means the other end point of the true length line B, we should lie on this locus, both in the front view as well as in the top view. You know that the true length is same in both in HP and VP. Therefore, by using the compass with A dash as center, take a radius of 70, cut an arc on the locus of B. So that you will going to get that point B1 dash and you mark this as capital A and capital B here. Why it is capital A and capital B? Because he has given that it as the true length line. Similarly, with A as center, true length is same both in HP and VP. You know the locus of B in the top view also. So with A as center, take a radius of 70, cut an arc on the locus of B in the top view. And you mark this point as B2 and you mark this point as capital B in bracket. And this is the locus of B. So this is all. And join AB2 and A dash B1 dash. So these two lines represent the true length in the top view and the true length in the front view. You mark this angle as theta in HP, that is true length in true inclination with respect to HP, and phi is the true length with respect to true inclination with respect to VP. So this is how you will be able to draw the orthographic view of the given data. So once we transfer the given data, now what? I need to represent the front view and top view. So what we know the front view true length line. For that we have not written the top view, and you know the top view true length line. To this we need to write the front view. So how to do that? So you know that this is the true length in HP. Sorry, you know that this is the true length in the vertical plane. Why this is the true length in the vertical plane? Because it is parallel to VP. Where you can see the parallel to VP, you can see the parallel to VP in the top view. That means both capital A and capital B1 is in front of VP by 15 mm distance. But you know that 15 mm in front of VP is known. So I need to write the top view for this. But you have A dash B1 dash is only the view which you have got now. But to this I need to write the top view. So when you look from the top view, what happens? This is actually the top view line, which is AB1. So when you look from the top view, because already we know that A, it is in front of VP by 15. So if the true length in the vertical plane means what? It is parallel to VP. Both A and capital B1 should be in front of VP by 15 mm. So A is in front of VP, therefore B1 should also be in front of VP by 15 mm only. So by looking from the top view, you project that point B1 directly onto the horizontal plane. So you mark this point as A and you mark this point as B1. So this is the top view line for the front view true length line A dash B1 dash. So here this is the top view line. Similarly, you know this is the true length in HP. So what does it mean? It should be parallel to HP. Both capital A and capital B2 are above HP by 20 mm. So if you look from the top view, that image will going to fall on the horizontal plane. True length in HP means what? It is parallel to HP, so it can be seen in HP. Now you know the top view of the true length. But to this I need to write the front view. Where should I look from the front view? You have to look from the front view like this, from this. So when you project this point, both A dash and B2 dash is parallel to XY line in the front view. Since it is parallel to XY line in the front view, so obviously that line will be in true length here. So A dash B2 dash is the line which is parallel to XY in the front view. To this, correspondingly in the top view, you have AB2 which is the true line. So you mark this as capital B and you mark this as capital A in bracket. So this is how you will be able to analyze it in 3 dimensions. But how to write that in 2D? So when you do that, you can see. So we have written this and we have written this. Now what I want? You know this is the front view true length. So you have A dash B1 dash. But to this I don't have the top view. Similarly, you know this is the true length in the horizontal plane. So that means you have the top view for this, but to this I need to have the front view. You don't have the front view. So first we are going to start from the front view. So you know this is the front view true length. Why it is called as the front view true length? If the top view line is parallel to XY, how I can say that is the true length in the vertical plane? The true length in the vertical plane, because you have capital A and capital B. If it is the true length in the vertical plane, obviously that true line will be parallel to VP. So that line should be parallel to VP. Where you can see the parallel to VP, I can see it in the top view. So you have the front view. For that, what is the front view line? The front view line is A dash B1 dash. But what is the corresponding top view? The corresponding top view should be AB1. But you have only A, you don't have B1. So I need to create that. So what I will do, I want to write a top view for this line. So I will be looking from here. If you look from here, what happens? A is in front of VP by 15. So what happens to the B1 also? The B1 should also be in front of VP by 15. That is what you can see here. This line is also 15 mm in front of VP, and this line is also 15 mm in front of VP. When you look from the top view, these 2 points will going to be the top view point of AB1. So that is what. So you draw your vertical projector from B1 dash till to the locus of A in the top view, because both A and B1 are in front of VP by 15 mm only. A is in front of VP, which is already given by the problem. So B1 should also be in front of VP by 15. Then only the line will be parallel to VP. So since it is parallel to XY line, therefore in the front view you will going to get the true length. Similarly, now we have the true length in the horizontal plane. What does it mean? The true length in the horizontal plane means the line has to be parallel to HP. If the line is parallel to HP, therefore you are getting the true length in HP. Then if you so that means you have the top view line, that is AB2, but you don't have the front view line of the corresponding top view. That is AB2 is the top view in the true length. So to this I need to write the front view. So what is the front view? Instead of A, you are going to have A dash. In B2, you will going to have B2 dash. But you have A dash, which is already fixed, which is given in the problem. So since it is parallel to HP, that means A dash is above HP by 20. So B2 dash should also be above HP by 20 only. That is, then only the line is parallel to HP. Since the line is parallel to HP, so we are getting the true length in HP. That is what we have shown. Since the line is parallel to HP, so you are getting the true length in HP. So how do I get the true length? If I want to get the front view, so A is above HP by 20, B2 should also be above HP by 20. So therefore, from B2, you project the point directly to the 20 mm above XY line, and you mark that point as B2 dash. So now this is the line parallel to HP. So you are getting the true length in HP AB2, that is capital A and capital B. So this is the true length in the vertical plane. That means AB1 is parallel to VP. Therefore, you are getting the true length in VP. So you got A dash and B1 dash. This is how you will be able to write the data which was given in the problem. And we were able to find out the front view true length and also, the top view true length and also the front view true length. Now we will go to rotate. How to rotate? See now. Well, so with A center taking the radius of capital AB1 in space, you are rotating such that B should also be in front of VP by 60 mm. So how to do that? With A center taking the radius of AB1, you draw an arc in space till where? Till that B1 will going to cut the locus of B in the top view. So if you are rotating like that, what happens? This B1B is also being rotated. So what happens? When you look from the top view, the image of this, that is B to B1, is the image that will going to be rotated till it comes and touches the locus of B in the top view. So once you get this point we will call this as small b. Then join A to B with a dark line. So this is how you will be able to find the top view for this problem, and you write the notation as beta. Now similarly, how to show that in the orthographic view? So you know that this is AB1 which is parallel to VP, but due to the presence of locus of B in the top view, the B1 will not be in front of VP by 50. Instead, the B is in front of VP by 60 mm. Then, with A center, taking the radius of AB1, you draw an arc such that it cuts the locus of B in the top view, and you mark this point as B. And okay, so this is how you will be able to write the top view of the true length. This is how you will be able to find the top view length and also the corresponding inclination with respect to BP, which is beta. Then join AB with a dot line. Next. Now, similarly, I want to find the apparent length and its inclination in the front view. So, how to do that? So, where is the front view? The front view point is AB2. Why? Because that line is parallel to HP. Now, but B2 is not above HP by 20. Instead, B2 is above HP by 60 mm above HP. So then what I will do? To take this line which is in space. With A center, taking the radius of AB2, you rotate it such that what happens? This B2 dash which was here will also start being rotated till where? Till it cuts the locus of B in the front view. So as we get the locus of B in the front view here, what happens to the image? Image which was there in B2 dash in vertical plane is also being rotated such that it will coincide with this particular line which was projected from capital B to B dash, so that it will go to cut the locus of B in the front view, because the locus of B is 50 mm above HP. So that means, in other words, this B which was here is being rotated such that this will going to become above HP by 50 mm. So once you get to this locus, then join A dash B dash with a dark line and you mark this angle as alpha. So how to write that in orthographic view? So you have this still here with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will go into cut the locus of B in the front view. So you mark this point as B dash, then join A dash B dash with a dark line, and then you measure, you mark the angle as alpha. Similarly, you mark the angle as beta here. So since he has to ask for the apparent inclination, so alpha is the apparent inclination with respect to HP, which is 34.02. Theta is the inclination with respect to HP, which is 25.38 degrees. Then phi is the true inclination with respect to VP, which is 40.01, and phi is being the inclination with respect to VP, which is beta, which is 45.36. And show all other dimensions. Like this. So this is how you will be able to analyze the problem. In this problem, they have given the locuses and also the true length of the line, but they asked us to find out the apparent inclination and also the true inclination. What is the apparent inclination? The apparent inclination is the apparent inclination with respect to HP is alpha, apparent inclination with respect to VP is beta, true inclination with respect to HP is theta, true inclination with respect to VP is phi. So how do I know that my problem is right? So you know that this is the true length in the vertical plane. Since it is the true length in the vertical plane, obviously that line should be parallel to x phi in the front view, top view. So this is A dash B1 dash, which is the true length in the front view. Obviously in the top view, that should be parallel to x phi. So you can see AB1 is parallel to x phi. Therefore, you are getting the true length. Similarly, you know this is the true length in the vertical plane because that line is parallel to x phi line in the front view. If the line is parallel to xy in the front view, correspondingly in the top view you are going to get the true length. So that is the reason why you have capital A and capital B. So you got this. Then you know this is the front view line. Why? Because the correspondingly the top view is inclined. You know that this is the top view because correspondingly the front view line is inclined. You know that this is the true length in the front view. Obviously in the top view that line should be parallel to xy. Yes. You know that this is the true length in the top view. Obviously that line should be parallel to xy line in the front view. So this is how you will be able to analyze and find the apparent length and its inclinations with respect to both HP and VP, and the true inclinations with respect to both HP and VP, which has been denoted by phi and theta. Apparent inclination with respect to HP is alpha. Apparent inclination with respect to VP is beta. So this is how we will be able to measure up to the second decimal point. You get the accuracy when you are doing it in CAD. So this is how you will be able to analyze the problem and solve the problem in analyze the problem manually. So by checking that both B and B dash will always lie on the same line. If it don't lie on the same line, then your drawing is a mistake. So this is our final takeaway from this. Thank you.